Okay, we have a little bit of arc length and Euler's method and integration by parts on this one, which you can use your formula or you can use your tabular method, your shortcut here. So it gives us a little table with F prime and then gives us what H is equal to. And right away, I kind of recognize that was like our arc length formula right there, which is going to help us out for letter B. But if H is the integral of all that stuff, and it's asking us to find the value of H prime of pi. So if H is the integral, then when you do the derivative of an integral, you're just going to get that inside function there. And technically, you're multiplying by the derivative of that x, which is just 1. Like if that was an x squared right there, then you got to multiply by a 2x there. That's your second fundamental theorem of calculus right there, right? So then there's your h prime, and then you're supposed to just plug in pi. And then they told us on our table that f prime of pi was equal to 6. So I did 1 plus 6 squared to get the square root of 37 right there. And then practice all this as a no calculator problem, that Euler's method. That's typically always on the no calculator section of the test. And then for part B, it says, what does this information mean? This is what we did earlier in the year. This is your arc length formula. That's the integral of the square root of 1 plus the derivative squared. That is your arc length formula right there. So you have to mention arc length and over the interval between 0 and pi. That will get you your full credit right there. Anytime there's numbers attached to that integral, make sure you're utilizing those numbers and be specific as possible. All right, so letter C, using Euler's method, gives us the starting point, 2 steps of equal size to go f of 2 pi. So if I'm going to go from 0 to 2 pi in 2 equal steps, that means I got to go 0 pi, 2 pi. And then they told us f of 0 was 0. So we're starting there. And then set up your Euler's method. We're going to go x, y, and then we're going to go delta x times dy dx, which means the delta x is your step. You went pi and then another pi. So the delta x is the pi. And then we're going to times it by the dy dx. So I need to take the delta x, which is the pi, and times it by the derivative, add x equals 0. So I'm going to go pi times f prime of 0. F prime of 0, they told us was equal to 5. So just multiply 5 times pi to get 5 pi for that. And then you're supposed to add up these two numbers here to get your new y. This is like your old y plus the change. And then you're going to get that new y right there. And then you'll take that number and drop it down. And then we'll do the same thing. So the delta x is pi. And this time we're at x equals pi. This row is x equals pi. So you're going to figure out what the derivative is at pi, which is on our table, which is just 6. So we'll get 6 pi there and then add those up to get 11 pi. And so that's the point, 2 pi comma 11 pi. That's your final answer right there. So that's going to be pretty straightforward, pretty easy, like our other methods problems. And then I really like part D because I actually did it both ways. And like I knew I did it right, like when I got the same answer for both of them. Um, but you don't have to do it both ways. You probably don't have time to do it both ways. You're going to go on to the next problem. But notice we know to use integration by parts. So if I'm doing the BC test, integration by parts is an added technique that's different than AB, other than your UDUs and your E's and L's, and like partial fractions is also on the BC test as well. So the integration by parts, the instant you see a normal thing, kind of like a weirder thing, or a normal thing times a harder thing there, that's going to be integration by parts there. So I use the shortcut. I let my U be the t plus 5, took that derivative down to 0. Remember to alternate the signs, started with the plus and alternate the signs. And then my dv was that. I could integrate that. When I integrate the cosine, I get a sine, but my u is the 1/4 t. So the du is 1/4. I need to balance that 1/4 with the reciprocal of 4 and then do the same thing. So I'm going to get a negative cosine because the derivative cosine is a negative sign. So if the negative's not there, put the negative there. And then same thing, you got to balance it with a 4 each time. So then that's where it was negative, and then I balance that with another 4 to get that 16. And I do that times that times that. And I was able to get that answer right there. Or if you don't want to use the shortcut, you can let your u be that, your dv be that. So remember what we do on the integration by parts is we typically try to let the dv be the harder looking part of the problem as long as we can integrate it. And I can integrate that, and just be careful with your balancing. And then you got your easy formula, uv minus integral v du. So you remember, take the derivative, do an integral. So I did that times that, wrote it down, minus the integral of that times that. And then you got to integrate it, and then you're good with that whole problem there. So just practice all that. No calculator, we could really get it. And if this kind of caught you off guard, now we know that arc length formula. That's what that looks like there. Sink full of dishes. Man, I need a dishwasher.